All right, so we have what we call higher order derivatives. So basically, we can take the derivative of a derivative, or the derivative of a derivative of a derivative, or however many you could possibly imagine, depending on the degree of your function. So if f is a differentiable function, then its derivative f prime is also going to be a function. So we can find the derivative of f prime, which we refer to as the second derivative of f. So notationally, there's lots of different ways we can say the second derivative of f, just like there's lots of different ways that we can say the derivative of f. So we could say f double prime of x. We could say y double prime. We could say dy prime dx. We could say d over dx times dy over dx. We could say d squared y dx squared. All of these just mean the second derivative of f. And if we took the derivative of the second derivative, we'd have the third derivative. And so we'd have triple primes. And if we go higher than that, then we put in parentheses to denote what derivative we're talking about. And so fourth derivative or higher, we put in parentheses. So if we have the function f of x equals x cubed minus x, and we want to find the first four derivatives of this function, f prime of x, we would use our power rule here, so we'd bring our 3 up front, we'd take 1 away from the power, and then with x, the derivative of x would just become 1, so we have 3x squared minus 1 for our first derivative. For our second derivative, f double prime of x, we take the derivative of this. So the derivative of 3x squared minus 1, we'd have 6x to the first, or 6x, minus 0. Derivative of a constant is just 0, so just 6x. For our third derivative, f triple prime of x, the derivative of 6x would just be 6. And then we could also find our fourth derivative. So we would have f, and then we'd put in parentheses in our superscript there 4 of x. And our triple prime was just a constant, so our fourth derivative is going to be 0. So there we can find higher order derivatives.